Okay, so today we are going to figure out how to find a perfect profit maximizing price if we know cost and demand functions, which we already talked about. Part of it is you need to go out and get data or do some research to figure out what the demand might be, expected demand, and what the cost would be. So take a moment, if you're just watching this video for the first time, take a moment to read this to familiarize yourself with what the demand represents and the cost represents, and then come back to the video. Okay, so the next thing is, the next page is the assignment. Okay, so what do we have? I've put the demand and the cost functions back up on top. And what we're going to do is we're going to just make a table. I didn't make you guys fill out the whole thing, but I want you guys to figure out at least part of it so you can understand how it all comes together. So the demand function, okay? Okay, again, your assignment is to fill out the missing blanks right here using the demand and cost functions. So I'm going to show you an example of a few. Okay, first of all, quantity. All you do is you take the quantity, the 0, right? And you take it and you plug it into right there. Okay, and you multiply it. So 0 times anything is 0 plus 50, and that's how we end up getting 50, right? Okay. Now, if you don't sell anything, and it doesn't matter what your price is, you're not going to make any money because nobody's going to sell any or buy any, right? So that's why the revenue or the sales, another word for revenue is sales, is 0. But let's talk a little bit about where we get the cost from. Well, maybe hold on. Let me keep going with these three columns right here. So the next thing is, if we sell one, we'd have to sell it at a price where we plug it in right here again into that equation. It tells us the only way we're going to get at least one would be if we dropped our price to 49. And then if we drop it to 49, the revenue or sales is just going to be, again, the quantity times that. So to figure out the revenue, all you do is basically take the quantity and the price. The price is what you're going to use the equation for. Now, after a while, you can figure out patterns. You can say, hey, every time quantity goes up by 1, how much is price going down? What do y'all think? Just 1, right? Price goes up by 1, it goes to 49, then to 48. Now, that's if it's linear. So the assumption here is that this demand function is linear. It's not always linear in the real world, but I just as we're learning this, the math is easier if we make it linear. So I'm just going to do linear, and then later I'll talk about what if it's quadratic or exponential. But anyway, that's what you can do is basically once you get the price by using the equation, you can figure out the revenue by multiplying quantity times price. This times that, this times that. 3 times 47 is 141. Okay, so that takes care of the first three columns. Cost. Now for the cost, we're going to use this function right here. Now there's a few things you're going to figure out about the cost. I don't know if the description talked about the 100. Let's go back to it. Yeah, it does. Okay, so if you read this carefully, it says that each lawn is going to cost her 20 based upon the time she would spend. So she's factoring in her time. She's saying, you know what, I could go work at a minimum wage job and get $20 an hour. So every hour I spend out there, I want to think about the cost is $20. That's what I'm losing if working here versus working somewhere else, right? They call that opportunity cost. So she thinks about that as her cost. And so every time she mows the lawn, she says, I need to get at least $20 to cover my cost. Assuming that it takes an hour for mowing and cleaning up a lawn. Now, what's the 100 though? The 100 shows up no matter how much quantity there is, right? It's what they call a fixed cost. Maybe she, like it says here, she has to rent a mower. Maybe she doesn't own her own. She goes to one of these places where you can rent a mower, I guess, and she gives them 100 every week. So if she mows 0 lawns, she pays $100. If she mows 1,000 lawns, she still pays only $100. That means it's fixed. It doesn't matter how much you do, you're paying 100, and that's it. That's called a fixed cost. And if you look at the function, you can kind of see that the hundred's there. It's what they call a constant, no matter what. All right, so now that we understand that, that's why even though the quantity is 0, we still have a cost, and your profit is actually negative, which would be a loss. So that's actually a loss. So that's how we get the profit. It's basically going to be this revenue minus this cost as your profit. I'll talk about marginal revenue, marginal stuff in a moment. You need at least 2 rows to get marginal stuff because it's a difference between stuff. Okay, at this point, are there any questions about how we get these first 5 columns? Quantity, price, revenue. Quantity I'm just giving to you, but you guys have to figure out price, revenue, cost, profit. All right, if you understand that, Then the second row would come from doing that. Now let's talk about the marginal. Does anybody know what marginal means? Marginal? Marginal means like, have you ever heard of something, it's on the margin? Well, it means as one thing changes, how does the other change? As it gradually changes, what's the change in the other thing, right? So marginal is like the extra. In this case, extra something, whenever I change the quantity to 1, how much do the other things change? It's really like the slope. A slope is kind of a marginal thing. It's like I change my x by 1, how does my y change? That's kind of a marginal thing. The extra, a good word for that is extra, when you increase quantity by 1. Well, let's check it out. So marginal revenue. Well, when there was 0 quantity, the revenue was 0. When there's 1 quantity, or a quantity of 1, the revenue was 49. So that means this is going to come from here. This is 49 is going to be the revenue from quantity 1 minus the revenue from quantity when it was 0. So that's what 49 minus 0, basically, okay? And then 47, where did that come from? Well, that was from 96 now minus 49. So basically, it's just tracking every time I increase quantity by 1, you can see revenue's going up, right? But it's going up at a different amounts every time. And that's what's called marginal revenue. So over here, you can see it's going up, yep, but it's going up less and less a little bit each time. All right, any questions about that? Because that part may be a little bit tricky. But that's how you get it, okay? So again, I'll just write down one of the equations. So 96 minus 49, right? 96 minus 49 equals 47. And that's why this one over here is 47. Okay. Now marginal cost. Marginal cost, if you look at the cost equation, it's really, remember I said it's like the slope? Well, it actually is the slope. If you look at the cost function, remember the number multiplied by the variable, in this case, it's not x. We're so used to seeing x. But in this case, Q is like the independent variable. So the number multiplied by that, that's like your slope, right? Like mx plus b, it's like the m, right? So 20 is literally going to be every time your quantity goes up by 1, you're multiplying it by 20. So that's why that's the marginal cost. You can just look at the equation and tell, right? And it stays the same each time. Every time she mows another lawn, it's additional $20. Okay, now the marginal profit, where do you think we get that? Well, again, profits, revenue minus cost. So basically it's as simple as going 49 minus 20 is equal to 29. So you're just basically subtracting those out, okay? So that is how you do it. So I'll let you guys try the next row. Give you guys a few minutes to try the next row, and then we'll go over it really quickly together. And so what does everybody try that?